So here we're going to construct this halftone effect on this photo using trapcode particular. And this will get you thinking about how to use trapcode particular creatively rather than just emitting particles. So let's make a new composition. Let's call this halftone and make a new solid for particular. Apply trapcode particular. And I need a photograph to use. I'm just going to copy this composition that I've got and paste it into this comp here. It's just a stock photograph that I've used, and I put a little scale animation, so it scales from 0 to 5 seconds. So it's actually doing something. So I'll turn this layer off. Notice that it is a 3D layer. And if I go into my particular settings, I'll set the emitter to a layer grid. So this is going to emit from a layer in a grid formation. So I need to define the layer. I'm going to use the photo. And you can see that it's taking the color from the photograph and emitting in sort of a grid. We can't really see it because the particles are moving around too much. So let's set the velocity to 0. Now we can kind of see the grid shape, but the grid shape is way too small. And it's also using the color from the photograph. We want to use the lightness dash size setting. So as the photograph goes from dark to light, is going to drive the size of the particles and make that sort of halftone effect that we're getting. But now we need to really size up this grid. So we do that in the options up here at the top. Click on options. I'm going to set this to 70 by 60. We're getting pretty close. We see sort of a feathering on the particle, which is its default setting. So I'll set the sphere feather to 0 so we don't have any feathering on it. And I'll turn the size down just a little bit like that. Now we're mostly there. From here it's just a matter of tweaking a couple anomalies that happen using grid emitters. And you notice right here that my particles disappear. Now what's happening is our particles have a lifespan of 3 seconds. So I could turn this up. But then what's going to happen is we're going to get particles that end up overlapping at that 3-second mark. And it's not going to be the cleanest way to do this. I want to show you the actual right way to do this if you are using motion video or whatever in your photographic pre-comp. That we need a very short lifespan, because if your photograph changes from frame to frame and we have particles emitting on every frame and their lifespan is 8 seconds, you're going to get all kinds of overlapping particles here, and it's not going to work out quite well. What we need is a lifespan that is equal to 1 frame in duration. So I could calculate this out, or just take my best guess, but actually what I'm going to do is use a very simple expression for this. I'm just going to go into my particle life, alt-click on the stopwatch, and type this comp period frame duration. This comp frame duration is going to be equal to the frame duration of my particular comp. So in NTSC or PAL or film or whatever you're working with then, your frame duration is going to be different. So this will be the exact duration of 1 frame, and it's actually very low. It actually rounds it down to 0 in the view here. So now my particle life is equal to 1 frame in length. So if my comp here changes every frame, my particles should be emitting on every frame. So I need a lot more particles here. If I go in my particles per second here, if we think about this, if we are emitting on every single frame and we have 70 times 60 particles times my composition duration, which is 30 frames per second, or actually in NTSC, let's set this to the exact frame rate, 2997. What this ends up being is 70 times 60 times how many frames per second. It ends up being quite a bit. This is equal to 125,874. It's a lot. But we want to make sure that if this composition here is changing on every frame, that our halftone effect is changing on every frame as well. The only way to have this changing on every frame is to set the particle lifespan to a very short duration, so that's only 1 frame at a time. But we have to have a very high particles per second count because, well, we've got a lot of particles we need to emit, and they are emitting in very short bursts. So now as this pre-count changes over time, these particles are going to reflect those changes. And even though we have such a very high particle count here, particular is actually very good about reacting very quickly. So don't worry about the high particle count here. Particular will act just fine. Now in the very first frame, we've got a little black frame here, and that's because we aren't emitting particles yet. So if I turn this up to 100, we've got particles on our first frame now. And now we've got a nice little particle halftone effect. Now if I turn this photograph back on, I can check the preserve transparency switch so that this photograph will observe the transparency of the layers below it. And we can actually get sort of a color halftone effect as well, mixing the original photograph with the particular layer if you'd like to do so. So we'll just turn that off and do a quick render.